Hey, Al Gonzalez here. I wanted to record this video to kind of help parents who might be looking at some of the stuff kids are bringing home for math and going, what is this man teaching you? Especially to let you know that what we are doing here and learning is real math, not fuzzy new math that people are like complaining about for the last bunch of years. This is the type of reasoning that mathematicians do to figure out actual problems. And the reasoning kids are doing in here is going to help them in 7th grade continue their ratios and proportions so that they can better be ready for 8th grade algebra. So I'm going to take the quiz because kids got to take their paper quiz home, and hopefully they showed it to you, because if they got a bunch wrong, you want to take a look at, maybe work with them and say, hey, what did you misunderstand? Chances are it's this whole unit rate thing. It's pretty confusing. But let me show you how we are using ratio tables to problem solve. On assignment 62 in the Math Google Classroom under Quiz Reflection, I put a digital copy of the quiz because some kids, since they took it home, forgot to bring it back to school so they could finish their reflections and fix the ones they got wrong. Meaning they have to finish them at home because they left them there. So I'm going to take this first question. 3 trains leave a station and travel towards their destinations. Train A travels 45 meters in 1 second, right here. B, 150 meters in 3. And C travels 256 meters in 8 seconds. And they had to order them from the slowest train to the fastest train. So let's take a look at how we could start. After the quiz, I showed kids who got that one wrong, hey, if you take the very first train, Train A left the station, and let me do meters per second for A, meters per second for B, and meters per second for C. So here's what I did first. As you can see here, I set up 3 different ratio tables to figure out the different ratios. I'm assuming the ratios are different, and by setting up 3 different tables, I'm going to be able to figure this out. Now, train A went 45 meters in 1 second. Here's what we learned in class. Any ratio which compares 2 numbers where one of the numbers is 1 is what we call a unit rate. One of these 2 numbers has to be 1. So this one is already a unit rate. So I told the kids, hey, don't mess with that one. Now the second one, train B, was 150 meters. Well, I'm going to move some of this stuff down because I'm not going to have enough room to do my work. Okay, 150 meters in 3 seconds. And train C was 256 meters in 8 seconds. Okay, now for this one, I've got a number that just jumps out to me because I can do 150 divided by 3. And the reason I'm doing that is because if I divide 3 by 3, I get 1. That means I've got 1 second here that I can compare to 1 second here. I want to compare unit rates, and I want to make sure my unit is the same thing. It's the seconds. Because if I make meters 1, I can't compare that to 45 meters. It's not the same distance. So in order to reason proportionally, I have to divide both sides by the same amount. So I'm either scaling up by multiplying or scaling down by dividing. Well, I know that 15 divided by 3 is 5, so then I know that 150 divided by 3 is 50. All right, so I already got my unit rate for this one and my unit rate for this one. Already I can see, and here's what kids need to figure out as they're looking at this. Train A went 45 meters in 1 second. Train B went 50 meters in 1 second. Notice I'm not saying it went 50 seconds per meter. I'm saying it went 50 meters in 1 second. So they have to reason which one of these two is the faster. The one that went the shortest distance in 1 second, or the one that went the longest. But we still need to figure out train C. Okay, so now let's do the third train, C. Now, if I want to get this to a unit rate, the quickest way I can do it is 8 divided by 8 to give me 1. Now, if that is too complex a jump, because students don't want to do 256 divided by 8, they could scale down by 2, go to 4, and then cut that in half, and then keep scaling till they get to 1. They could do that, and that's totally acceptable. But I want to show you, oh my gosh, select the eraser. There we go. But I want to go back to doing it in one move. So I'm going to figure out 256 divided by 8. Now that is going to scare anyone who's like, oh no, not divisions, not long division. Well, I'm going to say you don't really have to think of it in terms of long division. Let's do an area model, which is really helpful because we started the year learning how to calculate surface area, and we needed to figure out area of two-dimensional shapes, like a rectangle. So kids should know this. If I make one side 8, because I know I'm dividing by 8, where does the 256 go? Now, it's not the side, because area is length times width. So the 256 has to be the area. So if I've got this as an area, I'm like, okay, what do I know? Well, I know that if I break this up into a 240 square unit rectangle, oh, I can multiply 8 times 3 to get 24, so 8 times 30 will get me 240, right? Well, what's left? If I already took away 240, that means I've got 250 is 10, and 16, oh, and that's going to be way smaller. So 16 is actually probably right around there, 16 square units, right? So you see how I'm reasoning here and how I figured that out without having to do this whole long division thing that many people forget. So 8 times what is 16? It's 2. Well, looky there. I've got 30 and 2 is how many meters this train will go in 1 second. So if I go back to my original problem, this poor train only goes 32 meters. This one goes 45, and this one goes 50. So my slowest ends up being train C, and my fastest ends up being train B, and then A is in the middle. So what I was able to do, and what I helped students realize, is they got the question correct. They just got a 3 out of 4 instead of a 4 out of 4 if they figured it out correctly, but then switched which one was the fastest and the slowest. Because honestly, I was way more interested in their proportional thinking, in the fact that they could do this right here. Okay? If they were able to reason proportionally and use reasoning, mathematical thinking, and thinking in huge jumps. I mean, remember, if you do the 256 divided by 8, you're thinking in single digits. Does 8 go into 2? No. Does 8 go into 25? I'm thinking 3, 24. You see how I'm just thinking 8 times 3? Whereas in this one, I was kind of forced to think in a bigger magnitude. And that is a way better reasoning model than thinking in these single digits. Plus, kids don't know what's happening here. Why am I taking away, and why do I have to move over, and if there's a decimal, where does it go? So I say you can do so much and actually get better at math if you use an area model or even a ratio table to do your division. And like I said earlier, if you wanted to go down in smaller increments, so 8 divided by 2, because most of us can cut things in half. Like half of 200 is 100, half of 50 is 25, half of 6 is 3. 25 plus 3 is, so I can keep cutting it in half. And then I do divided by 2 again. And kids are thinking proportionally. They're just working their way to figuring it out in fewer steps. That's more sophisticated. So I know this is just one problem, but it shows you the type of math that you might see your kid doing if they're in front of you trying to figure this out at home. So if you see them using ratio tables or double number lines where they're figuring out this is 0, 0, and they've got, 256 is the same as 8. So then where does 1 go? All the way 2, 3, 4, 5, 6, 7. I mean, it works like a ratio table. I'm still dividing by 4 or dividing by 8. Divided by 8. I'm getting to this, what goes there. It works the same way. It's just horizontally instead of vertical. So I hope this gives you a glimpse into what kids or how they're learning to reason through ratios and proportion, because now we're in unit rate and it's proving to be a bit more challenging than unit 2. And it's because of they have to make sense of what they are trying to figure out. I think it's more the way the questions are asking for deeper thinking than the math, because I've seen kids do the math. And I've got most of the kids here are able to use a ratio table and think proportionally. So I'm going to do a little more practice, and if you're helping at home, I hope this gives you a good start. And message me anytime if you need to know, hey, my kid did this, what does it mean? I'll be happy to help.